Hi, this is Jason Harrington from the University of Florida, and I'm here to show you how to do numerical analysis at home. Now, the first step I would always suggest is, particularly with these larger cathode ray tubes, you want to go ahead and turn them on first, and there we have the green light indicating that the monitor is on. It usually takes a few seconds to warm up. The second thing I want to do is I want to look for my operating system. Now, in this case, I went ahead and picked ProDOS 1.02, which is about 83 to 84. It did last for a little bit. I put it back into the computer, and then now I'm going to go ahead and hit start, which is over here. The computer has now booted up. Turn off the lamp so you can see the beautiful green glow. Now right now there's nothing on it, it appears, but if I type in cat or category, this will actually bring up the list of programs that I have written that are available on the diskette. If I type in load, L-A-D, L-O-A-D, and I type in square root, S-Q-R-T, then my program will load. Now, if I type in list, you'll see this program appear. Now, before I get into how it works, I want to remind you of the bisection method. For the square root of n, I'm going to take square root of n is equal to x. I square both sides and I bring the n to the other side, and now I have this function which I'm going to call x squared minus that n. If I put in n, it's positive. If I put in 0, it's negative, and I can use the bisection method. So let's take a look how this works. The user will type in n, or type in a numerical value for n. A is going to be 0, B is equal to n. The error is going to be 0.0 with actually 7 zeros and 1. That's the highest machine tolerance for the Apple II. The midpoint is going to be C, which is the average, B plus A divided by 2. And I'm going to have a true or false statement to know if I'm going to replace C with what. So if C times C minus n is less than 0, then I'm going to replace A with C. If not, I'm going to replace B with C. And then I'm going to take the absolute value of A minus B, and if it's bigger than the error, go to 60, which is way back up here, and it repeats, and it will keep going until you can actually, until it gets within the tolerance. Now, if I hit run, it will run this code. Please type in a positive integer. If I hit 5, I'm going to get 2.23606,798. Now, let's look at it a different way. Well, before I actually leave this, what I want to do is if I want to print this out. So I'll come over here to my printer. I will turn on the printer. Okay, you can see that the printer line is on, and you also want to make sure that your dip switches within the printer are actually max set. This is why it's always good to keep the manual to your printer. Otherwise, you won't know which dip switches and which hexadecimals will actually go through with each of your different command lines. All right, so to print, I'm going to type in PR pound sign, and then I type in 1. That means print channel 1. And if I look at the computer and I hit enter, it has now been set. But nothing has occurred on the screen. And what I'm going to do is I'm going to type out list, L-I-S-T, and you'll notice nothing came up on the computer monitor. But if I hit enter, it is actually printed out. Now, in order to stop the printing mode, because now anytime I hit on the keyboard it will print, I'm going to hit Control Reset. You'll hear a little beep indicating that you're back in the terminal shell and you're all good. Now I want to type in new because I want to remove that program and enter something new. I'll go back to cat, and then I will look at say, let's load in square root, in square root, and I hit enter. I hit load. Whoops, I'm gonna hit run, sorry. Let me just see if I have list, just make sure it's still loaded in there. Okay, so there it is. Now you may ask what all this stuff is coming from. The first initial guess is just n divided by 2. And this is going to be a nice little simple for loop in 4 steps. And this formula right here actually comes from using Newton's formula. If I set x squared minus n from the previous problem, the derivative is 2x. And then I simplify it out, I'm going to get 0.5x minus x over a. Or n over x. And up here, my initial guess is a, and we get a is equal to 0.5 times a plus n over a. Now if I hit run on this thing, oh, sorry, mistyped that. Run, it'll say input a positive number, you get 5. And you can see the steps that we have. We actually have 0, 1, 2, 3, 4, 5. So the 0th spot was the initial guess. And now you're going to get 2.3606798. Now a lot of you may be asking, how do you know if this is correct? How would you double check a computer like this? Well, that's of course why we have our handy dandy little slide rule. And also it's very important that you keep the computer manuals that come with the thing, because a lot of times, you know, I'll forget how to do something. So if I look in the Apple manual, you'll see this is how you can load and save and all these little ProDOS commands that are very needed. So if I want to know how to do the square root of 5, the first thing I'm going to do is I'm only going to look at the A and the D, right? So here's what I do. Like for example, let me just do one that's really simple. I'll set this over here real quick. Now over here, I have A, which is 4, and then my D is 2. So whatever your A column is, you don't actually have to move the middle piece of wood there. You just have to use the A and D slot. So if I go over here to 5, and I'm looking at 5, okay, let me zoom in on this a second. Okay, so there's 5. So I have 2. This is 2.1, 2.2, and these little ones in there are increments of 2, right? Because it goes 2, 4, 6, 8, 10. That's the next step right there. So that's 2.1224. So it's 2.24, which matches in the rounded of our computer system. So the computer seems to be matching with our slide rule. So that gives a good indication that the technology is working. Thank you.